Everyone, wonderful to have all of you here. I'm sure that this is going to be a very useful event for all of you. And this is in continuation after a very long time. I started teaching how to write secure code long back in 2002, and I started there at a company called DE Shaw. Those who you are not, you may not be aware of. All right, so let's get started. Welcome everyone. This is Sandeep Piri. I'm going to talk about secure programming. This is going to be a little more technical talk, as in we expect you to be aware of the basics of programming and so on. So without further delay, let's get started. Wonderful. So the topic for today is basically secure programming. I'm going to walk you through the snippets of the code, and you need to look at the code and see which line is having a bug and what kind of security bug the code is having. So that's what the format of this session is going to be like that. So please respond using the YouTube chat and be proactive in asking questions. All right. So about myself, I'm Sandeep Viri, and I started my career long ago in 2002, and my first job was at DE Shaw. I graduated from IIT Roorkee, which is a very good institute and pretty old institute, old in the sense that it was probably oldest, second oldest, I think, in Asia in engineering. And I worked with D. Shaw, and there I realized that a lot of engineers did not know how to write secure code because it wasn't part of anybody's graduation degrees, or it wasn't academic discipline. So though people talked about firewalls and people talked about encryption, but writing secure code was not on people's agenda. And basically they thought that coding practices would lead to good code, stable code in production, and that's secure enough. No. When I was at DISH, I demonstrated for the internal tools what kind of bugs existed in their systems, and thereby we created an internal group for auditing the code. This was 2003 or 2004. I have worked largely into the computing, into the large scale computing and machine learning. And recently, somebody requested me for the secure coding, and especially because the people who have attended my talks earlier were very inclined to attend similar talks. So some of these things might look a bit arcane or a bit older, but when you look at them closely, they still exist. I used to report all kinds of bugs, and a couple of bugs I've reported in past and are related to Liferay portal and Times of India, Times of India email. All right. So that's about me, and I love explaining technologies and teaching people technology and even how to hack and so on. And and that's one of the reasons why I founded Cloudxlab. And I basically love machine learning, distributed computing, and understanding the security side of code. And the more I worked with different engineering teams in Mobi, Amazon, and even my own startup right now, the more I'm convinced that that it takes a long time to learn how to write secure code. All right, so let's get started. This is going to be a bit technical session. So be ready with maybe a pen and paper, or be ready with notepad, and try to think of the code, and that's how it's going to be. All right. A brief intro about Cloudxlab. At Cloudxlab, we are trying to make learning fun and for life, and by the way of videos, quizzes, hands-on projects, and case studies. Take a look at Cloudxlab projects under Learn. You'll find the projects under Learn, and you're going to like those projects. Those projects are mostly about machine learning and big data and DevOps, but you're going to actually, be more hands-on. So this is the environment which we have designed at Cloudxlab. On left hand side is the problem statement. On the right hand side is the playground. And when you click on submit answer, it checks the playground and basically gives you feedback. And this is actually pretty neat because this is this is basically reviewing your work in Jupyter, and you don't have to save any file or anything. It basically checks in memory. All right, and basically at Cloudxlab you get a good environment to play around with. So you take a look at Cloudxlab, try to use all kind of technologies. That way you will get comfortable. So you get console, you get real world experience, and you get the centralized data sets, and you basically can access from any device. In case you're accessing from, let's say, iPad or something, just change it to the request desktop one, because the Jupyter doesn't allow in that. All right. Now coming back to it, so at Cloudxlab we have social profile, and people can interact with each other by the way of forum, by the way of following each other on Cloudxlab, and people can also see who all have attempted and how popular is a particular course. Also the jobs, specifically basically we have lots of jobs. You can take a look at the job section and just check if you are qualifying for a particular job. So the various recruiters keep posting jobs and people keep applying for the jobs. So this is fairly popular, and this is really helping people. Now let's get started. Okay, so one of the first things to understand is what exactly is security. This word is something that we have been acquainted with for very, very long time. But from the perspective of the computer security, security is first one, confidentiality. Confidentiality, as in we call it secrecy, or sometimes we just call it privacy. Okay, so confidentiality, secrecy, or privacy, the whatever assets are there in a system, they should only be read or accessed by authorized parties. That's what is confidentiality. So a computer system should ensure that we have these three kinds of security in place. Okay, so first one is confidentiality, or we call it secrecy. Second one is integrity. The assets or the computer resources or any online assets should only be modified or deleted or altered by the various authorized parties in authorized ways. Okay, see, if a person is only allowed to modify certain things, only that person should be able to modify. It should not that somebody else can get access to the modification of data, right? The third one is a very interesting one. This third one, third pillar, third part of the security came pretty late, which is called availability. The assets which are accessible to authorized parties, which is, as per confidentiality and right. So whatever assets are there on your website or on your server, whatever assets are there, they should be accessible to various authorized parties in timely manner. Meaning, one person should not be able to stop the other person from accessing the data on timely manner. All right. Like for example, if you have a website, it's a great website. Let's say think of Wikipedia, for example. But if I start spamming or cause the denial of service at Wikipedia, the information access to many people will stop, right? This is called the denial of service. In the beginning, it did not look like threat, right? But soon enough, when there was an attack on Yahoo and there was an attack on multiple servers, so multiple other service providers, there, what happened was that when the servers are blocked and users are not able to use their email, it's essentially killing the confidentiality and integrity. I mean, not integrity, it's actually not letting the people use your system, and thereby it was counted as one of the big, big important pillars of security. All right, though this was added the last. I hope everybody is with me so far. Now, this is probably the most least technical part in the whole session. Now let's move on. All right. So when we think about the computer security, this is the diagram you should keep in mind. All right. So this is your server, this boundary that you see. I'm not very good at trying, so okay. So this is your server here. We call it like the kingdom, Unix or Windows server, whatever you want to call it. This is your server, right? And outside, there could be an attacker, okay? And in there, in this kingdom, there are certain processes or certain services or certain programs which are run inside the admin area. Okay, this is normal user area, this is admin area, and there is an attacker outside. If there is a service which is running, if there is a service which is running as administrator, so when in any computer, when you are running a program, when you double click on calculator on your Windows desktop, you are essentially launching a program, right? You are converting a local file, a file as in which is stored on the hard disk, you're converting that file into a process, right? And when that happens, this basically, when the process is running, process is an ID, and a process also has something called owner, right? Who it is running as. When you are running a calculator on Windows, it is running as you. Okay, I'll focus more on the Unix side because that's the way most of us would focus on security. Most of the researchers that would attend, or most of the people who will attend the discussion, they would be more comfortable with talking about Linux because that's how most of the websites or servers generally run. Okay, now coming back to the point is that When you run a program, it is run as the person who is executing, right? But there are some programs, like for example, the program that changes the password file, the program that changes the password, right? Even though the password file is supposed to be read only, but anybody can change their password, right? Such programs, such programs are called setuid. Such programs are called setuid. So when such a program runs, when such a program runs, this program, instead of instead of running as you, it becomes some other user, usually the root user or the admin user. All right. These are called setuid programs. The examples are like, for example, password command. Password command, when it runs, it becomes the root, right? It's called setuid root. Though you are running it, but while running, it becomes root. If, let's say, you're running a command like ls or ps or any other Unix command, it will always run as you yourself, right? So this admin area contains those kind of programs which, when executed, becomes the system administrator or become root. Okay, and basically this here, it shows that such programs which are setuid are vulnerable. Are vulnerable. When you run such program, you could become admin. Okay, and if an attacker attacks such a program, what happens is the attacker would become the root. Okay, so there could be a service which is running as root. Earlier, mail server and everybody used to run as a root. But soon enough, people figured out how to secure those, right? If there is a service like mail server, they will run as, root. And if the attacker attacks them, they will directly become the admin, right? And if the attacker attacks a service or a program which is running as normal user, they will become the normal user, right? So for attacker to get into the admin side, they'll have to first attack a normal process which is running as normal user, and then they will attack the root area. So the moment you breach either this boundary or this boundary or this part, in any case, it's a breach, and it could lead to the loss of any of the three. Okay, it could lead to the loss of any of the three: the confidentiality, integrity, and availability. Okay, so keep in mind this diagram, that in a Unix system, there are processes who are running as root or setuid programs. There are processes who are running as root and are exposed to the world. Then there are processes who are running as normal user and are exposed to the world. So attacker could attack this, or this. Okay. To attack this setuid program, the attacker needs to be a user first. Okay. So basically, a very close attention need to be paid into understanding what kind of applications need to be secured, right? What do you think that, what are those softwares, right? I whenever I talk to people, when I explain to them that, hey, you need to learn to code and so on, right? We will not learn to code, write secure code and so on. So the general answer is that, hey, the kind of application I'm building doesn't need to be secure. And this is a very common answer, okay? This is a very common answer. But if you look at closely, almost everything needs to be secure, okay? everything needs to be secure. And you will understand that if your program is designed with proper understanding of what needs to be done, if your program is designed for designed with proper software design principles, and you have an understanding of what's going underneath, then your program will not only be stable, will also be secure. Okay, so it's very important to keep security in mind. And the main challenge that I see is not understanding the real issues. Okay, so long back, somebody when I long back when I was attending a talk by some person who was demonstrating how secure is his application or software. He only talked about he only talked about the he only talked about cryptography, encryption, and firewalls, routers, gateways, and antiviruses and port blocking. But one thing that he had overlooked was the writing of the code, secure code. And writing of secure code is hard. Okay, it you will have to understand bottom up. You have to look at the code from closer perspective with full of suspicion, right? That this code might let attackers into your system and so on. So unlike the usual coding, unlike the usual programming, when you think about secure programming, you look at the code with complete suspicion that anything could break down. All right. So similarly, whether you are building the viewers of remote data, such as browser, applets, email client, word processor, and for that matter, notepad. Okay, for that matter, notepad. Your system, your application need to be designed with security in mind. Okay, any application programs that are needed to be used by administrator, right? So the application programs, such as, let's say, you've designed a program which administrators will use um, in order to review the disk storage on your system or log viewing on your system. So let's say there is a server and system administrators are using your tool in order to assess the storage of the server, right? Now, you might argue at this point of time that, hey, such kind of programs don't need to be secured. No, an attacker who is inside here could attack such programs. And basically, if these programs are not that secure, the people could become the root or the administrator by the way of these programs. Okay, so you need to be extremely careful. I'm going to give you a brief demo as in by the way of code. I'm going to talk about that. Third kind of programs that need to be secured are servers, of course, like local programs, network accessible server, for example, FTP, Talent, SSH, Apache web server, and Sandman. So, so by the way, Apache is not only Apache Hadoop. Apache is an independent web server, and that's how the term Apache was was introduced into the open source world. Okay, and The other examples of servers that need to be secured are the web applications. Okay. Third one is the set UID, set GID program like password. So by now you must have noticed that almost everything, almost every kind of programs need to be secured. All right. So big question is how? Quick answer is paranoia is virtue. Be extremely paranoid while writing a code or reviewing somebody's code that how this piece of code can be attacked or exploited. This is the thumb rule that I follow whenever I'm doing auditing for any code, that the paranoia is virtue. So focus on what could break in a code, where is the input coming, and what exactly is the code doing. So it's a hard thing to follow, but there is no better or there's no other way. Okay, I'm going to talk about situations and patterns, but the important part would be to build a paranoia. Okay, like for example, let's say you are writing a code for yourself, and you don't feel like doing too much work, and you don't want to secure things when you are doing it your own. But trust me, that would build bad habits. When in production, you will end up causing the similar bugs. Okay, now let's get started. So the structure of this session is around these parts. First, I'm going to talk about validations of inputs, the examples, different types of inputs. Then I'm going to talk about buffer overflows. Then I'm going to talk about software practices like this, how to structure your program's internals so that your program has less security bugs. Then how to send, then talk about sending information back to the user judiciously. And then I'm going to talk about language specific issues, C++, Python, Perl, and shell scripting. Though Python is missing here, but I'll be having, we will have one chapter on Python. All right. So the first piece of advice to all is that whatever is the user's input, properly check the input for valid data. All right, now here we go. Here is a code whereby we are authenticating a user. Select something from a table where user equals single quote, and then the double quote ended. This is string from here that was started here, it ended here. And then the user ID, which has come from the user when he has provided the login, or she has provided the login, and then double quote, then followed by single quote, and password equals single quote followed by password, and then single quote. All right. Yes. Anybody, please feel free to answer. So essentially, we are forming a SQL query by concatenating the username provided by the user, or by substituting the username provided by the user and password provided by the user. So it's going to check in the users table whether the username provided by the person is correct, as well as the password is correct. Okay. So what are the bugs that you see in this? There are many bugs in this I'm going to talk about, but I want to see if you can get it. Anyone? Feel free to. All right. Okay, go ahead. Yes. I'll answer general questions later. Okay. So do you see anything wrong with this? Anyone? Select something from a table where username equals user ID provided by the user in single quote and password equals password provided by the user in single quotes, right? So yes, there are many bugs in it. Yes, thank you, Noor. So essentially, it has something called SQL injection, okay? And yes, there is no semicolon. I think there is a semicolon. Okay. All right. Oh, there's no single quote, you mean? No, actually, there is. If you see, strings are in double quotes, and then there is a single quote here, and so on. So these single quotes, I need to change their format. That's another important thing. Okay. All right. Now, notice what happens when somebody enters this admin single quote. So admin followed by a single quote. If somebody enters here, so in SQL query, this single quote will be added here, and then there will be a syntax error, right? Okay. So because why we have this single quote? Because SQL expects that we write single quote, strings in single quote, right? And these double quotes are from, say, your programming language, whether you're using Python, C, or anything, right? So these double quotes are from that. Though these double quotes look really ugly, and these presentation, Google slide and Microsoft PowerPoint, they keep on changing my single quote and double quote into these weird characters. So this is a single quote, this is a double quote, then single quote, then here again single quote started, then double quote, and then so on. Okay. So I hope this is clear to all. Essentially, this single quote is part of the string. Okay, the string started here, ended here, this single quote is here, and so on. Okay, so if a user is entering a single quote here, it will cause SQL error, right? SQL error. So it will become, this query will become select something from the table where username equals single quote admin, then the single quote twice, right? Because we entered extra single quote here, right? Admin, single quote, and then again single quote. This single quote is coming from here, this single quote is coming from here, and this single quote was entered by the user, right? So basically, this would throw a SQL error. Okay, if the user at this point of time comes to know about the single quote, that single quote is causing SQL error, that means the attacker would know that this code, this server is prone to SQL injection. This bug is called SQL injection because the user will be able to get into the SQL and modify, right? So how? What if the user enters admin, single quote, and then dash dash? Dash dash means the comment. So what will happen in this case? Yes. So double dash means quote, as in comment out. Double dash means commenting out. And everything after that point where dash dash occurs gets commented out. So what will happen to your query? Yes. So what will happen is that this will convert your query into select something from table where username equals admin, and double dash. So everything after double dash is commented, right? So basically, though this piece of code looks okay, but if you put this code in your server, if you put this code in server, what will happen is anybody can log in into your server without any password. Okay, without any password, and you will be surprised to know that every server has this kind of bug. I mean, not guaranteed, but lots of servers have had this kind of bug. Okay, so if you enter something like admin single quote double dash, you'll just log in into the server. And the example that I was quoting earlier in one of the talks, somebody was giving on how to secure application. The person had just focused on routers and firewalls and cryptography. So I asked him that, hey, can you just give me the URL? And I told him that if you enter login like this, you will log in. Anybody can log in into admin without any password. And all the firewalls and everything is just rendered useless because this can give you the control of database directly without having any access to the database directly. You will be able to manipulate and modify the queries, right? This just changes everything. Okay. All right. All right. Please do not use the comments for self promotion, and please use the comments for asking questions. Okay. It's only going to distract everyone and disturb everyone. And okay. All right. All right. Wonderful. So I hope everybody is able to relate to this. Imagine user further writes admin single quote or 1 equals 1 dash dash, right? What will happen in that case is they will also further make sure that in case let's say password check is before username. So I remember finding this bug in somebody's code. So so the first thing they defended is by the way of placing JavaScript, which checks whether there is single quote in the HTML, a single quote in the form or not. Okay, so what they did was they removed single quote and all these special characters from the from the input in JavaScript, right? Now, the truth is that you can always disable JavaScript in your browser, right? And when you disable JavaScript in the browser, whatever form you're submitting, it doesn't have the sanitization and hence it reaches the server. So that was the first mistake to defend this, okay? Second mistake to defend it is by the way of, by the way of So one very important thing that happened, I never imagined that people could get so creative, is that they swapped the password and username check. Okay, so it became select something from table where password equals password and username equals username, right? So it got swapped, and when you put comment, the nothing gets commented, and therefore this query will not work. This username will not make you log in, right? But you could enter things like admin single quote or 1 equals 1, and you could still log in into such application. So instead of playing or doing the tricks or trying to solve the problems by the way of improper code, use a proper way, as in, while taking the input from the user, validate all the input. Check. Just take only the things that you are allowed to. Okay, not the other way. Okay, so there are two ways to looking at validation of input. First way is accept accept what is right and reject everything else. Right. Second way is reject what is wrong. Okay, so when you reject what is wrong, that's a wrong strategy. Okay, instead accept only what is right. Okay, because if you try to reject what's wrong, your subset of wrong could be very tiny, and therefore you will end up missing out lots of things. So instead of rejecting or removing what is, illegal or wrong, or what is like malicious code, so instead of trying to do that, do the other way. Accept what is the valid character. Allow only the valid character. Everything else is removed. Okay? And keep this in mind always. Now, again, this is an older example, but you will see similar instances everywhere when you are, let's say, writing a system in which there is a they need to send email, or you're writing a system in which you have to send an email. You might use a system command. The system command invokes the mail program that sends the email, and here you are taking the form data and sending the email. So this error or this bug had been in most of the servers for a very long time. So they use the system command and so on. Now, do you see anything wrong with it? Anybody? Yes, that's right. So basically, this is wrong in many ways. Even this is wrong in many ways. I'll talk about the other parts later. Like, for example, you should not be saving the password as is. Instead, you should encrypt the password and keep it there. Compare the encrypted password. Okay. Now, coming back to the point I was trying to make is that if your program is sending email and they're using the system command basically executes the any command from the system. Okay, instead of you using API or library, you are using the system command to send the email, right? What you're using a command called mail. Mail is a Unix command that sends the email. Now, what's wrong with this? What exactly is wrong with this? What if the user writes the email like this, in a valid email address followed by semicolon, and then another command saying mail space hacker at some email ID at and there's this angle bracket and etc password. So what's happening here, that this concatenation of string mail followed by this form data, the email from form data, is forming, it's essentially forming um, a command, okay? And if you put a semicolon there, the command will be ended, and then the user can type any command of their choice. So if somebody enters in email address, if somebody enters this, it's going to be disastrous. It's going to be disastrous because the the user will be able to send the password and other details to himself, or may actually do anything on your server, right? So this essentially gives the entire control to the user. All right, this essentially gives the entire control of your server to the user. Okay, so this is extremely critical. This is something, these are the mistakes that we all do. Just that these mistakes here, they are looking very obvious, but in reality, what will happen is one system reading the email address from user, other one translating it, third one calling some other API, some other process, and that process further calling the system command internally. Okay, so the whole process is little more complex in a bigger application, and therefore you would not notice these bugs. Okay. Now, first principle, as I just said, determine what is legal and allowed, and reject anything that does not meet the definition. But do not try to do the reverse. Okay, do not try to delete what is illegal and accept everything else. Okay, and trust me, most of the engineers, they do the reverse. They will try to remove all the malicious characters and then keep whatever is not malicious. Now, defining malicious could be very hard. Therefore, defining what is non-malicious, what is illegal, what is correct, what is accepted format, accept that. Okay, so do not try to figure out what is malicious. Instead, figure out what is a valid email address, right? Email address contains characters from that are A to Z, 0 to 1, underscore, dash, and then followed by one single @ followed by the domain name. So use the regular expression, use the only valid character set. Okay, so instead of doing the other way. All right. So like for example, if you are trying to compare an email address, this kind of pattern could be good enough. Okay. So try to look for a regular expression. Okay, how to use regular expression. You can take a look at my YouTube channel. There you'll find some chapter on regular expression. And this could be a valid regular expression to define an email address. Okay, those who are new, I can just give you a brief. Here it says that alphabets, capital A to Z or small a to Z, and then followed by this, followed by @. So any valid characters, 0 to 9, alphabets, underscore, comma, plus, at, followed by domain name. Okay, followed by domain name, and that's about it. So basically it says that first character has to be alphabet, followed by anything these many times. Okay, so like that. So there are many email validation regular expressions. Use those, and similarly learn to use regular expressions, because that way you'll be less lazy in putting the validations properly. Okay, so, because accepting what is valid is something that is in your control. Okay, when you do not know how to pattern match, what will happen is you will end up trying to remove malicious characters. Okay, and malicious characters are not finite. There could be many more, and as the time progresses, the attackers will figure out more malicious characters than you might think. Okay. All right. Great. Moving ahead. So now, similarly, the input from the user comes in many forms. It's not only the normal form, but it also comes in the form of cookie values. Users can modify the cookie values. Let's say you're building a web application, and web application has cookies. You know what are cookies? Cookies are essentially that extra data stored in your browser that goes along with the request that you submit to the server. Every time you are browsing the website, the cookie data is going on every click to the server, right? When you're clicking on something and the request is going to the server, automatically the cookie data gets attached to the request. That's cookie data. So cookie is essentially the data provided by the user. You can modify cookie, you can modify the internal header of the request. You should take a look at when you right click and click on inspect, you should take a look at what request is coming from server, what is going, and so on. So you would know what all information is going to the server, right? So while accepting the data from, while accepting the cookie values, okay, consider that as the user input. A number of times what I have found in my past is that people think that cookie values are something that user cannot modify. They can all the time modify your cookie values, okay? So keep that in mind. Also, whenever you are accepting cookies, check if the domain value for any cookie you are using is the expected one, just like user's input. Just like user's input, you should validate the cookie values. Okay. Also, one very important thing that you have to keep in mind is that a number of times your parsing logic itself is bugging, and that could lead to the escalation, that could lead to all kinds of problems. Therefore, when you are parsing the input, temporarily drop all the privileges. Okay, and this is how a number of systems actually build. This is how a number of systems are built. While parsing an input from the user, drop all privileges or even create separate processes. Okay, now here is a little older hack, and this might not work right now, but it's important as an example. Okay. So somebody just wrote this program which is calling the date. You wrote a C program. You wrote a C program which is supposed to display the date, right? So all you did was in your code, you used a system command. System command basically invokes the local command. And using system command, you invoked date. Okay? Can this program be hacked? Can this program, which is invoking date, be hacked? Yes? Anybody? This program is running as some other user, not you. But when you run this program becomes somebody else, maybe root. And this program is essentially setuid. We call this program setuid. And when you run this program is invoking the command called date. Do you think that this is safe? No. If the attacker creates another command called date and changes the path such that the date is picked from the user's directory, okay, and would be run with the privilege of the admin user. Okay, now the attacker's command, date command, will be executed with parents' privileges. Now, what will happen is, and this used to happen, and this basically many systems got hacked using this technique. That somebody created a program called date, and when we ran this other program, which was invoking date, the modified or malicious date was executed. Okay. Now, so quickly, the developers fixed the problem like this. Instead of calling date with relative path, they used the absolute path. Now, can this be manipulated? Can this be manipulated? Not directly, but yes, right? So what you can do is, in such case, what attackers did was they set IFS equals slash. Okay, IFS is internal field separator. When you are passing a Unix command or running a Unix command, based on what is IFS, the command line arguments are passed. Okay, how basically using this separator, the command line arguments are separated. By default, that's a space. Okay, by default, IFS is space, but the moment you set it to be slash, what will happen is this command will become like this: user space bin user date. So bin and date are arguments, and this is the command. Now, the attacker could do the same thing what they did in the previous case. They would set the they would basically set the path such that user command is there in that path, and that user command will be executed. And this really happened. This really happened. Okay, so this is how lots of systems got attacked earlier. Okay, I mean, most of the bugs that you will see even today will be on similar patterns here and there. Okay, now very important part if you're writing a server or any kind of program or any kind of set UID program which could be run by many users. So reset all the variables. For example, set IFS equals this. Okay. Now, always extract and erase environment variables and set these according to your needs. And of course, don't call the system command. Figure out some other way of calling the system command. Okay. Now, in case it is must to use the system command, then ensure that your environment is cleaned up. Should not load the environment by default. Instead, erase the environment and have your own variables. Okay. The other examples or situations of validation of input is, let's say you're building a web server or FTP server which takes the file names, right? And this actually happened. Okay, so there was this FTP server which was not designed properly to handle the file names. So if you keep on going up, and so on, you might actually reach to the top level file, okay, and therefore can access anything. This actually happened in past in FTP. So when you are handling the files, make sure that your logic is correct, or the way you are handling the URL is correct, and ensure that you don't use the wildcard characters. And in case you're using wildcard characters, you have to be extremely careful. Okay, so the file input could the inputs could also come as files. So input could come as direct input from the user, right? Inputs could come as direct inputs from the user. Inputs could come as the environment variables. The input could come as the file names provided by the user, or the URLs that are coming around, and so on. Also, the input could also come from the contents of a file. So if a program is taking directions from a file, this file should not be trusted. The user, the developer of the program need to be very careful about reading the instructions from a file. Ensure that this file is never exposed to the user. Okay, and this has happened multiple times. Like, for example, one of the common bugs that exists in most of the server even today is this, that they allow you to upload images. Okay, they allow you to upload images, and inside image, let's say you write your Python program, okay, and rename it to JPG. So there is a Python program which has marked on it that this is internally the first line of any Unix program tells how to execute that program. So and you rename it to rename the program to .jpg, upload it to server and access it. Okay, and access it. Now, while accessing, lots of servers make mistake. Okay, they end up executing the Python program instead of giving you, considering it as like JPG and giving you to download. Okay, this actually used to happen very often. This is another reason why many people prefer to go with S3 or Amazon CKR store, Amazon S3, right? So people, that's another reason. Okay, so if you're building a place, a system whereby you can upload images and upload files, you have to be extremely careful, extremely careful. Okay, so generally, let's say it is inevitable for you to get the file upload from the user. So ensure that you don't keep inside, do not keep inside the normal folder of web server. Instead, put it somewhere outside, and the web server should not run the program. Instead, there should be another program which would read this file and give it to the user instead of web server trying to serve it directly. If web server tries to serve the program directly, it might end up executing the program. So be very, very careful if you are serving back the images or files the user had just uploaded. Okay, these programs might be something else. Okay, and this is so common. This is so common. This is so common mistake that almost every web developer ends up doing this mistake. And this is how many systems got hacked in past. Many systems. Almost every server running PHP was prone to this bug. Okay. Now, the next very important idea is cross-site scripting. Okay, so I published a couple of bugs in past in 2003, 2004, 2007. So usually the bugs in software programs used to be published in a mailing list called bug track, and it is basically a very active mailing list. And people basically, I mean, it was a big thing to get your get your bug published in these online newsletters or mailing lists. Okay, so long back, what I observed is that almost every service, be it Yahoo, Google, Hotmail, India Times, Orkut, and I found a bug in Orkut Rediff, but Rediff fixed very quickly. India Times took time to fix it, though I published it publicly, though they don't run their email system anymore, and so on. Even I published a bug on LiveRay. It's an open source portal. So coming back to it, what exactly is cross-site scripting? If let's say one user is uploading data on your server, let's say on a discussion forum, and the other user is reading it. Now, if this user is able to write JavaScript into his code, and this JavaScript is executing for another user, right? That could lead to lots of vulnerabilities. Say, for example, I sent you an email, and this email had JavaScript, and this JavaScript basically steals the cookie data, your session ID, and other things, and sends it to me. Okay, if I send you an email with JavaScript enabled in it, and your mail client is not handling the JavaScript properly. So what could happen is that if your mail client is executing my JavaScript, I'll be able to steal your session data, or the attacker could steal the session data and the other information. Okay, so cross-site scripting vulnerabilities, they were recognized as late as 2006 as serious threat. Okay, till that point they were not considered serious, but after a couple of demonstrations, they became, very important bugs. And as of today, they are really, really big troubles for most of the web applications. Okay, so cross-site scripting is something that is, there in almost every web application. So if let's say you are entering HTML and you can also enter JavaScript, and I show it to other users and your JavaScript gets executed there, that's cross-site scripting. All right. Now, a common thing that people followed was let's say user entered JavaScript and delete everything from starting with the script till script. Do you think it has problems? Yes. So if you delete everything starting with the script till the script, what would happen? Do you think that will secure it? So basically, we were talking about validation of all inputs, right? And one of the things that is important is basically understanding the cross-site scripting issues. Cross-site scripting issues occur when the input provided by one user is displayed to another user. And if this input contains malicious code, or let's say JavaScript code, it could basically exploit other users' session details, or other users. It can hijack the other user's session or steal information from other user, right? So this is called cross-site scripting, XSS. That's how it's referred. And basically, the simple idea that would come to your mind is that delete everything starting with the script till the script is ended, right? This might sound okay to you, correct? My question to you is, do you see any problems with this? So if you're deleting everything starting from script to script, will it delete all the scripts? The answer is no. What would happen in this case? What if the attacker has inputted this script? Yes? If the attacker has inputted this script, what will happen is, let's say you delete everything starting with script till script, then from script till script. Now what will it form is, it will again form the script. You see, script, and then again script. So it'll again form the script. So the solution to cross-site scripting is not this straightforward. Okay. There could be many cases whereby an attacker can provide the evil code such that it can bypass your checks. Okay. What if the user has put the script in this form? Inside the bold, on mouse over, inside the image, in SRC you can actually put JavaScript. In href you can put JavaScript. In mouse over you can put, and image also you can put the JavaScript. Okay. Similarly, the other places there could be JavaScript, and the list keeps on going on. Okay. So There are so many places in HTML where you can put the JavaScript, okay? Where you could put the JavaScript. Other than this, whereby let's say you know that the server is going to remove everything from script to script, it'll again form script. You see, script, okay, and then code. So you can actually remove this. The attacker can come up with a script like this, even if you are removing the script, still it will form the script again. So there could be many more scenarios, and this makes cross-site scripting very hard. If you are taking the HTML from user, you will end up with many more security issues. Okay. So what if the input includes tags like this? IMG, dynamic source, input type image, and so on. So there are so many bugs that exist in various browsers, and therefore the better way is only allow very few tags. Do not allow all kinds of tags with all kinds of attributes. Okay. So have very minimal acceptance for the tags. Okay. Do not accept any other arguments in I, P, or BB. Just have very basic character set. You might have to write your own parser, your own basic tag parser by yourself, but that's okay. That's completely okay. Today, having an HTML parser or your own DOM parser is extremely easy. So use those. Similarly, while displaying the content from one user to another, translate less than sign with ampersand LT semicolon. And greater than, or this angle bracket, the closing angle bracket, this one with ampersand GT and so on. So convert the HTML to HTML code. So instead of the code being executed, the code will be displayed on the screen to another user. This way, at least the execution will not happen. It will just spoil the experience, a bit of experience for one user who is seeing this code on the screen. Second, you can use your own type of tags. Okay, you could use your own type of tags, image till image, and so on. Accept only legal characters. Okay, wherever possible, accept only legal characters. Remove ever. You don't need to actually remove special characters. Instead, accept only legal characters. Okay. And also, if you want, you can first remove the special characters and then accept only the legal characters. So though this I have mentioned it here, do not follow it so easily. Instead, just accept only the legal characters. And in legal characters, if you find that there are some special characters that you need to explicitly remove, then you can use this part. Here is the list of access cross-site scripting in more details. Okay. Now, another thing that I want to talk about is the buffer overflow. Most of the bugs on routers, on systems, and services in past are because of buffer overflow. This bug you may not be able to relate to because if you are not coding in the languages like C or C++. So buffer overflow occurs when you write a set of values into fixed length array, okay, and write at least one value outside that buffer's boundary. So buffer overflow is essentially trying to write more data into a smaller allocated array. And that was possible in the earlier programming languages. But the newer programming languages such as Java and Python do not allow buffer overflow so easily. A buffer overflow can also occur while reading input from the user into buffer, okay, and so on. So let's take an example. All right, so here's a very simple code. You wrote this very wonderful server in C. It reads the string from user and prints that string back to the user. Do you see any problem with that? Do you see any problem with this code? So here is a C code, which is basically defining a buffer of 100 characters, copying the data from the buffer, it's copying the data from argument into the buffer, and then printing the buffer. Do you see any problems with that? Yes? All right, let me walk you through this. If you run this program with an argument ABC, it will happily print ABC. Why? Because ABC is the first argument being copied to buffer and then printed, right? You're okay with this execution. If you give this program a very long string, it will give the code down. The moment this argument, instead of ABC, this argument goes really big, what will happen is we are trying to write big value into a buffer of 100 characters, right? If this is more than 100 characters, then this will overflow, right? This will give a code down. All right. Now, the second problem with this code is that if you provide, say, percent s a n d e e p, it will print garbage here. It will look garbage, but it actually is information about this. Actually is information about the internals of your system, the address space of your system. Therefore, this could lead to the exploitation of system. So it has two big problems. First one is the buffer overflow, and other one is the format string problem. Both are security issues. Okay, you might say that what big deal? Yes, you gave a big string, it gave a code dump, end of the story. How can you exploit this, right? If let's say this is a server running, which is basically taking the input from the user and printing it back on the screen. And in that case, if you gave this big string and gave a code dump, big string as an input and give a code dump, you can actually get into the server. You can actually get into the server and actually control it and compromise it. And the attackers do that all the time. Okay, just so innocent looking code is so easy and it causes terrible bug in the server. So even though it looks very obvious that okay, we are just copying the first argument in the buffer and printing it, what big deal, we are not really doing anything with system command or anything, right? Still, this is very much exploitable. This is very much exploitable. Let me walk you through this. I'm going to give you a very high level overview so that you get an idea about what we're talking about. So in your right, in your OS or in your the way compiler executes your instructions, the way it does is it has something called buffer. Okay. So whenever you're calling a function, what it does is it creates a frame. It creates a frame. This has basically data of the function the function arguments or parameters, and then the execution stack pointer, execution instruction pointer. Now, this execution instruction pointer is something that is very, very interesting. Okay, just give me a moment. I will basically set it up. Well, desktop seems to be heated up. Okay. All right. So I've just turned on the fan. Moving ahead. So when you are calling a function in a program, what it does is it creates this kind of a frame on a stack. Now in this, it stores all the variables of that function. It, it stores the function parameters, and in midway somewhere, it stores the execution instruction pointer. What does it do? This EIP tells the system where to go after executing this function. Generally, it finds to the previous function that called this. So this execution instruction pointer is the key thing here. So if your function is overwriting a buffer, it basically overwrites execution instruction pointer. And this is where that core dump happens or segmentation fault happens, right? Now, if you write the buffer such that you make it point to the buffer itself. So here, you could actually write the assembly code. You could actually write the assembly code, which can basically be executed. So if in this buffer towards the end, if you write if you write the address of the beginning of this buffer, you will end up executing the command inside the buffer. Okay, so this is basically the buffer overflow problem that had led to so many errors in the world, so many hacks and so many exploitation in the world that you can't imagine. Earlier, it was basically 60% of the bugs of the world were because of this problem. So an innocent looking code like this could be exploited, to get anything done, right? Anything done. And this is real. Just look for buffer overflow. Just look for buffer overflow or smashing the stack for fun and profit. Okay, there is this paper called Smashing the Stack for Fun and Profit, and take a look at that. All right, now how can you avoid the buffer overflow? The first one is understand the library. What are you going to use? Okay, and use the function correctly. Instead of using, if you are in C or C++, instead of gets, use fgets. Instead of using strcpy, use string strncpy. Correspondingly with strcat. With printf, when you're printing data, do not just printf like this. This is wrong because an attacker can understand the address space of your system by the way of this garbage. All right. So make sure that you instead of using printf without a formatting one, use the one with formatting. So always use printf with the formatted string. Okay, and then use the basically if you are trying to um, output the data or something, try to use the sprintf. Okay, and this will basically force to print this string in this format, and thereby you can control how many characters to print and so on. Scanf, okay. So always while scanning while scanning the data from the user, make sure that you only read fixed number of characters. Similarly, scanf reading from another string. So similarly, you can always specify these extra parameters of format. All right. So make sure that you follow this way. Okay. Next is that while writing code in C++, use the code checking utilities. There are many more libraries which are way more safer than the standard one. Okay. And there are many more compilers that have come up which basically try to avoid the buffer overflows. But it's very important to understand what exactly is buffer overflow and why does it happen, so that if you get a chance to do anything in C++, you are aware that this could cause a buffer overflow. Okay. And though other languages, the new generation languages such as Java, Perl, Python, and PHP, they don't have buffer overflows, but it is important to know what is a buffer overflow, because that will help you understand that a simple looking problem could actually lead to the entire compromise. All right. Now, here is a bit of non-tech, non-coding parts that follow the, structure your program's internals, follow the software engineering principles such as the economy of economy of simplicity. For example, KISS. Keep it simple, stupid. It's a very hard thing to do. It's though it's you know it's something so easy to say. Okay, to make something simple, it takes a lot of hard work. Okay, so make sure that you keep things extremely simple. Extremely simple. Okay, extremely simple as in which is obvious, which is something that the user can understand, you yourself can understand, and break down the logic such that it is simpler and simpler. Okay. Open design. This is another thing that, it took long time for engineers to understand this part. Okay. So very often people would not disclose their algorithms, and they'll believe that if you are hiding the algorithms, that means you are securing it, right? Lots of people, lots of companies did not expose or made their algorithms public, okay? Because they were afraid that people might try to break those algorithms. But it's actually the other way. If your design is public or design is based on the standard mechanisms, your design will be secure, more secure than the other people. Okay, so keep the design open. Do not depend on the ignorance of attacker, because attacker is ignorant enough, they do not know that you are using this server, or you're using this kind of encryption. Do not rely on that. Trust me, if you are trying to create your own cryptographic algorithm, the chances are that it can be hacked. Okay, so use the open design, use the open mechanisms. The world is so beautiful today that almost everything is open. Okay, so keep your product as open as possible. If there are issues, bugs, then you will get to know them very early, as compared to at very later stage where only few attackers got access to your server and they're exploiting it. If you had made the design public, maybe some other people could have come up and pinpoint that your design has these bugs. And yes, it happens all the time. There are standard policies in which the various security researchers report a bug or a flaw in your code, okay, in your program. And that's a wonderful thing. And that's how you actually can secure. So open design helps you secure your software and it is very non-commonsensical. Complete mediation. Every access attempt the user is making to your server, your application, you must check every step. Secure the interface. You should always have the interface very secure. Now moving ahead, the defaults in your application should be fail safe. What does it mean by fail safe? Okay, right? If let's say you build something, if it breaks, will it fall on you or will it fall on the safer side? So that design is something that you need to look at closely. You should design things in a fail-safe manner such that if it breaks, it should fail towards the safer side. Instead of falling on you, it should fall the other side. So that's called fail-safe design. So in case you see a problem somewhere, the default should be denial of service. You should basically, in case you can't handle a particular error or particular input, it's better to just gracefully deny the service, say that, hey, it's not available. Separation of privileges. Okay. So separation of privileges is very, very, very important. Defeating one protection system should not enable complete access. You should have labels of privileges. Okay. Then least common mechanism. Okay. Now this might sound like it is opposite to the open design, but it's just not opposite to the open design. Okay. So there are certain things which are cause of concerns all the time. One of them is like accessing the temp directory, temp files, and so on. So try to minimize such shared mechanism. Okay, they could lead to all kinds of race conditions and so on. Separate data and control. Now this has gone harder and harder every day from because of machine learning. The difference between the control and data is no longer that high. Therefore, you have to pay closer attention that your data and control should be separate. Okay. The other part is that your software should be easy to use. Okay. If your software interface is psychologically acceptable, there is a flow, right? Proper flow. There's basically the standard system. The chances of having a bug is very less. Okay. Now, if there are bugs, there are chances that if the interface or the way to use your system is not that straightforward, okay, or is confusing, what happens is the user's mental image is not matching with the way you have designed the system. What will happen is the user will end up finding a bug in your system. Okay, or user might end up breaking the system. So this is something, and also when your system is not designed as per the flow of user, the chance of the software being buggy is very high. Okay, specifically the security bugs. All right. Next one is a very important part. It is basically minimizing privilege. Okay, so basically, whenever, let's say, there is a web server or mail server or anything that you're designing, always minimize the total privilege that you're giving to the process. The time the privileges can be used and ejected, the modules that granted the privilege. So minimize all of these. Minimize the modules that are granted the privilege, minimize accessible data, minimize the resources available. As opposed to normal software design thoughts that let's give all the access to the software. Okay. Instead, do the opposite. Okay. So when you are, let's say, building a service, try to minimize the privileges that you give, all kinds of at every level, because it is better to have minimum privilege. Otherwise, what will happen is, let's say you were working on your desktop and you gave all the privileges, and when you went into production, those privileges were not there, and those access were not there, and everything starts breaking. So, design your software such that it gives minimum privileges as well as it uses minimum privileges to get something done. All right. So minimize the functionality of a component. Avoid creating set UID and set GID scripts as discussed in the first slide. Configure configure the system safely and also use the safety faults. Load initialization values safely. Okay. When you are loading the initialization of your system, make sure that you are basically loading them from a place, or the way you are loading should be, you know, validating inputs and so on. So your system should be fail safe, as I've already said. Now, next one is avoiding race conditions and saving violations. Now, this is something very hard. This is something very hard. Race condition is a behavior, unexpected behavior of the system, whereby two people or two processes are trying to compete on a resource. That's called race condition. Let's say two people trying to take the money from the same bank account, okay, and so on. So that leads to all kinds of race conditions. And if a system is buggy, okay, and race conditions are hardest. Race conditions are hardest to solve. Okay, like for example here, say you are trying to write data to the file. So first you did the check that if the file is existing and has proper permission, and then you waited for some time, maybe a millisecond or a second, and then you wrote the data to the file. Do you think there is something wrong with this approach? Yes? Okay. What if this file got changed in between checking and modifying data? Yes. So basically, this was a big problem, and this led to lots of Unix system compromises. That what happened was, an attacker will slow down the execution of the process by overloading the system, so that between checking the file and writing that to file, the file got changed. Okay, so somebody basically did a created a symbolic link, and when the program is writing to that file, that symbolic link got overwritten, right? And yes, and that led to so many compromises in the Unix. Okay, so there are many ways of avoiding race conditions. One is use locks on the files, use open function in C, create random name or file using, so when you're creating a file, make sure that you can use a random name file in the temporary location. And there are flags okay, which gives you exclusive lock on the file, okay? And almost every language have these issues. And it's not only Python, it's not only C that has these issues. Almost every language has race conditions, and race conditions are most terrible bugs to solve. Okay, so there are commands even in Java, in C. There are libraries which provide you a way to create temporary files. Okay, so use those. The last point is sending data or sending information back judiciously. Okay, as in when you are giving feedback to the user, okay, do not give the feedback in the entire detail. Like for example, if on the login screen, user tried to put single quote and clicked on the login, and your system had a bug of Sql injection, if you gave exact error message to the attacker, attacker will quickly figure out, that the information that the server has a security bug. Okay. Now, very important part again. Imagine for a time being there is this web service which is buggy, okay, which has SQL injection problems, and user can inject SQL and get any SQL executed on the server. Now, the problem would be for the attacker that how to extract data, how to download data, right, from your server. So what they will do is they will try to gather the data and try to cast it into a number as per the SQL query. And then, since your system will show an error saying cannot cast this string into this number, your program will end up showing, by the way of error messages, your program will end up showing the, the, the actual content of your database. And attackers can exploit that. Attackers can exploit your system if your system is displaying the full error message to the end user. When you're building a server or a service, show the full technical details to the developers in the logs. But on the interface, in case there is a bug in the system, you should generally deny the access and say that, sorry, we are not able to log in you at this point of time. Please contact such and such. Okay, so that way you minimize the feedback. Okay, minimize the feedback. Internal feedbacks, the feedbacks to the developer should be maximum, while to the end user, the feedback should be on the service level, on a very high level. Okay, it should not be, whatever error you're getting from the system, you printed it to the user. No, the user is an attacker. User is an attacker, and therefore user can exploit this information in his favor. Okay. Control formatting, whenever you are printing data, whenever you're sending the data to the user, send it judiciously. If you're sending a data that could contain malicious code from other user, control the formatting such that the script is not printed as is. All right. Also, allow on your server, disallow on your server the access to the configuration and other internal files. Okay. So make sure that anything that is not required by the user should be blocked. Okay. So this way, basically, any information that you're sending back to the user, you should control it. Even the information that you're using Python Django, you should avoid it, right? Because what attackers do is they basically scan your server using the penetration testing and so on. And then they basically figure it out quickly, what server are you using, and for that server, what have been the bugs. what have been the bugs in Python Django, what has been bugs in PHP, and so on. Okay. So while sending the information back to the user, please make sure that you keep them minimal. Now, there are many language-specific issues. Please look into those. I'm not going to go into details of each one. Okay. There are many more language issues with C++. Main one is buffer overflow, and and there are many more problems with malloc, alloc, free, and so on. So make sure that while doing the memory management, have the full control over the memory management in C++. Because there, if you make a mistake, you might end up with huge security flaws. Okay, so take a look at that one. Then, with respect to each language, Python doesn't have the overflow buffer overflow problems because the memory management is taken care by Python itself. And make sure that you follow the proper practices in case of Python. Say, for example, in setuid Python program should not import the user module because a lot of user module basically loads all kinds of defaults from Python RC.NET and so on. Okay. Also, since Python doesn't have a compile time checking, there are lots of bugs. Okay. Try avoiding exec, eval, exec file, and so on. Input statement is also surprisingly dangerous. Okay. So minimize these calls. Observe what is it that you're loading and so on. By default, I mean, in Python, there is not much of syntax checking like Java or so. Therefore, use say PyChecker to catch the bugs in your code early. By default, most Python projects are passed by reference. Okay. Also, never unpickle the data from an untrusted source. Okay. Because while you unpickle is converting a pickle format into Java, into Python's internal memory format. Okay. So basically, deserializing data in Python happens by the way of unpickling. So when you're deserializing, the chances are that during deserialization itself, your program could get hacked. Okay, or bugs in your program could get exploited. Therefore, this is data that is uploaded by the user. Do not unpickle it. Okay, do not deserialize it. Okay, Python is designed to be clean and highly reflexive language, which makes handling malicious code more difficult. All right. Similarly, in Perl, there are many hidden functionalities. If you do not know about those functionalities, they can be bugs. Like, for example, the open function in Python, in case the file name, instead of providing the file name, if you provide pipe followed by command, this command gets executed. Okay, so be aware of the library functions while using those library functions in your code. You should know these corner cases. Okay. So the thumb rule is that whenever you are using any library function, you should read its manual. If you have read the manual of string copy strcpy in C, you would, in the manual itself, it's very clearly written that this function is prone to overflow. Okay, so make sure that part. Now, coming to the shell scripting are bit disastrous when it comes to security. Fundamentally, every shell script is prone to race condition. Okay, race condition, because in the shell script, you can actually pause the execution of the script at any point of time, slow down this execution of the step at any point of time. Therefore, shell scriptings are very much prone to the race condition. Okay, so make sure that you use shell scripting only for yourself. Do not use it. I mean, it should not be used in a way that it is given to another user, which can be exploited. So I would say this again, that the paranoia is a virtue. Okay. So be paranoid while writing code. While writing a code, be paranoid. All right. Your code is going to be used by, your code will be executed by million times by millions of people, and be aware that people can exploit your code, and it could open the door for on the entire system. So that's pretty much. Thank you, everyone. If you have any questions, please reach out to us at reachus at cloudxlab.com.